Hello everyone, our project is building biomedical domain knowledge graph, and I will introduce our project in two parts. The first part is the data crawling, and the second part is graph building.
And here's an introduction for data crawling part. We're getting our data from organized dataset and crawling data. For organized dataset, we're getting data from DBpedia API, National Center for Health Statistics, and Cargo BME dataset. For crawled data, we are getting data from Wikipedia and Google Scholar. From Wikipedia, we're mainly getting data for those BME-related areas. But for Wikipedia, it's not limited the invitation for users. We can get data in a more simpler way. But for Google Scholar, it's a little bit hard for us to do that. So we are using high-level tools like Selenium or TOR, and we're using the mix of ScriptPy and Beautiful Soup to process the data that we're getting from the framework. The point that we're using to search in the Google Scholar are from the BME webpage of the top 20 BME schools in America, and the names are listed below. Under the biomedical engineering page, we can see that there are multiple paragraphs and a lot of links in the same page. And what we want is the context of the paragraph, the link, and the context of the link. And those we don't want is that the irrelative link on the side of the bar, or those links that are not so relative to the biomedical engineering part. And we are using the keyword comparison and some BFS to fetch the data that we want from this page. Here we can see the code we are using and citations we got from Google Scholar. For each school, we are getting 10 professors, and for each professor, top 10 quoted essays are crawled in whole name. And for each publication, we got 2 co-workers so that the complete knowledge graph can be built based on this. Name of each professor is using ISO standard to store. It's also the most convenient way to get the whole name of publications as well as separate name with publication. Google Scholar is using extremely strict captcha system and ID protection to provide data crawling, so we are using a mix of agent pool and Selenium as well as different cookies to avoid being banned. The detail for technologies we are using could be obtained in your paper.
In the knowledge graph part, we are first using the Wikipedia API and DBpedia Sparring QL to download the keywords in and build a knowledge graph. After that, we are embedding all the data together into our graph. And the data storage we use is MongoDB and HDFS. And the knowledge graph structure is built by the Neo4j. And here you can see that we are first use some keywords to query the Wikipedia to get all the information about the names and something else in the biomedical domain. And then we'll save all this information in here. And after that, we'll query these words in the DBpedia for more specific information about what they are meaning and what they belong to. For example, here we can see all the information here, and we will extract the features out and save them to the MongoDB. So here are something we saved. Let's see if this is a person or something else. It will show all the information abstracts there. And finally, we'll transfer this information, including the relationship between these two names and things, into the graph database to make it much easier to query. Like so, in this Neo4j, we can see we have so many relationships and nodes, and you can see each people, they are closed on how many they have published together, or where they are working at. And finally, we'll also merge the data query from the university and MongoDB together down into our graph database. And this is what we have downloaded and merged. So we have ground in the university web page, and then we will use them to back here.